Hello, my name is Beth Dixon, and this is a podcast on the system of equations solved by elimination. And as always, this presentation is designed as a supplement and does not replace your classroom instruction. Classroom instruction is always foremost the most important tool that you have for classroom for your learning. Let's get my mouse working again and get on with an example of a system of equations. Remember that a system of equations is a set of equations involving two equations and two variables. It can also involve more complicated problems, but we will not get into those in this example. Our equation is x minus y equals 11 and 2x plus y equals 19. And as we look at this set of equations, we want to see that our goal with this process of elimination is to add the two equations. Notice our x's are above the x's, our y's are lined up with the y's, the equals are on top of the equals, and the numbers are on top of the numbers. This means these sets of equations are really set up to solve with elimination. The next thing we want to do is when we add these equations, the goal of elimination is to eliminate one of the variables, either the x or the y. And when we add them, to eliminate them means it adds to be 0. And to add to be 0, we have to add opposite numbers. That means the same number with opposite signs. In this case, we can see that the y's both have an understood 1 in front of them. The first equation being a minus 1 in front of the y, and the second equation being a positive 1. So if I add a negative 1 and a positive 1 here and here, I will end up with these two adding to 0. In other words, they're canceling out. So what I want to do is I want to come in and I'm going to add these two equations. So I'll add 1x plus 2x, and that'll give me 3x, and I'm going to say a negative y and a positive y cancel each other out. 11 plus 19 equals 30. And then I end up with an equation with just one variable, 3x equals 30. I've eliminated, thus the title elimination for this method, I've eliminated the y's. Then I can solve for x by simply dividing by 3 on both sides. That then lets me solve for the x variable. X equals 10. Now remember, in a system of equations we need both the x and the y. The x value can then be substituted back into this top equation, and it can be substituted in for the x. So 10 goes in place of the x, and excuse all that pen changing information. Then the rest of the equation, minus y equals 11. So we're just plugging in the 10 in place of the x. But then we have to get the y by itself to find out what y is. So we just proceed with our solving equation skills. We want the y by itself, so we have to subtract 10 from both sides. That gives me a negative y. 11 minus 10 is 1, but remember we're not through until that's a positive, and remember there's an understood 1 in front of that, so if you need to write the 1 there, and then negative 1 divided by -1. And please ignore the crinkly, unstraight ones there. The pens don't write very straight. And we end up with a -1 for y. And then our solution then is x equals 10 and y equals -1. And we can write that as an ordered pair. Some teachers want you to always write them as an ordered pair. Some teachers will want you just to circle your answers. But we're not done until we get both the x and the y. So that's an example of solving with elimination. Now I'm going to bring this down a little bit, and I'm going to look at one more example in this set, and it's going to be (4x plus 8y equals -24) and -4x minus 2y equals -12. Notice in this case, again, the x's line up, the y's line up, and the numbers line up, so it's set up for elimination. We also notice that in this case, our x's have the same number and the opposite signs, which means it's set up to eliminate the x's. And as we look at this, I can add, and the x's will eliminate. A -4 and a +4, same number, opposite signs, will add to 0. And I don't need to write the 0 down here. That's unnecessary and will give us more in the next line than we need to deal with. I can go on and add the 8y and the -2y, which will leave me 6y equals a -24 and a -12. The signs are the same, so I keep the sign and add the numbers, and I get -36. Then I need to get the y by itself. I'm now into an equation with only one variable. I cannot solve an equation with two variables and get a single number, so I have to eliminate one of the variables. I divide both sides by 6, and y equals -6. 6 goes into 36 6 times. A negative divided by a positive is a negative. Then I take this and I'm going to plug it back in, and I can actually plug it in into either one of the equations, but just to keep things simple, I tend to always plug it back into the top equation. So that's going to give me 4x plus 8 times -6 equals -24. So that's 4x minus 48. 8 times 6 is 48. A positive times a negative is a negative, so that's -48 equals -24. Then I'm going to add 48 to both sides. And that gives me 4x equals 24. Divide by 4, divide by 4, and x equals a +6. And then my solution is 6, -6, with x being 6 and y being -6. If you write them as an ordered pair, remember always to write your x first and then your y. And again, some teachers will have you write them as an ordered pair. Other teachers are fine with you just leaving them as an x and a y. me bring that down just up just a little bit so that you can see that, because that probably was at the bottom of the page where you couldn't see. And we want to be able to see that completely there. And that is two examples of elimination. Notice in both of these cases they were set up to do elimination with no work. Most problems, though, you'll need to do a little bit of work before you eliminate. To see those examples, please watch some other podcasts where I will show you how to do those type of problems. Thank you for watching. If you need additional help, please come by the Math Lab in MBSS 222 in the Math and Behavioral Social Science building. Thank you.